Okay. So here's where we are on the calendar. Where's we are? So 0304, hello. I'll get emails from people going, when's this thing due? Beginning of every class, I talk about this stuff over here. Plus the due dates on the homework, which I did change to next week. But when you look at the due date on the homework, it's been changed. Okay, so 0.3, 0.4 today. The Pearson quiz number 2 on section 0102. That's due tomorrow at 5 p.m. There's 2 attempts, remember? I keep the better of the 2 scores. So if you don't like your first attempt, do it again. Second attempt, I'll keep the better of the 2 scores. If you need to see a video of the walkthrough, that's on the YouTube 81726. Go to the playlist. It'll walk you through how you do a quiz. On Wednesday, 8.4 and 8.5. 8.5 is the last section. More exponents, scientific notation. On Friday, 8.5 and review. Monday would be more review. And then we're shooting it Wednesday for the test. Okay, I haven't put it up here, but I'll let you know by this Wednesday. We confirm that up. All right. These substitution questions. This one is an application. It's a few centuries old. And this gives us the height, the vertical height of an object. If we know what the acceleration due to gravity is, the initial velocity that we put into the object, and the time in seconds. The units. But this also ties into dimensional analysis. -32 feet per second squared per time squared. So according to acceleration, it's negative because the direction is down. We're being pulled towards the center of the earth at 32 feet every second per second. That is the acceleration, because if something falls to the earth, it accelerates, it goes faster and faster and faster, ignoring air resistance. Because when we have air resistance, there's a terminal velocity. For example, Galileo the scientific method in the 1500s showed this, and he was excommunicated by the Catholic Church, and he was put on house arrest until he died. It wasn't until the 1960s that the Catholic Church said, oh, yeah, that Galileo thing, we were wrong. So our bad. And they said, he's okay. Because he came up with, or he proved, that the Earth is not the center of the universe, or the center of the galaxy. He also showed by looking through his telescope, the moon is not perfect. And the way he showed that we're not the center, where everything goes around the Earth, because the church was teaching everything at that time. The church was a leading, not just spiritual authority, but it was also political authority. So the church lost credibility in one concept. It's going to lose credibility in a lot of other things. Galileo showed that they're teaching about everything going around the Earth when he looked at Jupiter. He saw moons circling Jupiter. Everything's supposed to go around the Earth, then why are those little objects going around Jupiter? He found 7 moons in the 1500s using his rudimentary telescope circling Jupiter. He also showed, according to the teachings of the church, which were using teachings of Aristotle 1600 years earlier, which made a lot of sense. The heavier an object is, the faster it's going to fall down. The heavier, the faster it falls. Galileo said that's not true. Everything falls at the same rate. So he went up to the top of Pisa. It wasn't leaning, and it's no longer leaning now. And they fixed it. But he dropped 2 different weights of cannonballs, and they hit the ground at the same time, which disproves the idea of objects fall at different rates. For instance, which one's going to hit first? Yes, the yardstick. Okay. And that's not because the yardstick is heavier, which it is. Am I changing the weight of the paper?
No.
No.
No. Weighs the same paper. They hit at the same time. But what I took away was the paper's air resistance, the terminal velocity. So they hit at the same time. Gravity affects everything at the same acceleration. And that's something he observed back in the 1500s. And when he wrote about it, he didn't just write about it in Latin, which only scholars would be able to study. He wrote about it in Italian, so everybody could read it. And that was a big. Okay. Because not everybody has access to knowledge. And if you keep knowledge away from the masses, from the people, you keep them under control. The whole scheme that great knowledge power. So, an astronaut by the name of David Scott, one of the last moon missions, he took a hammer and a feather on the moon. There's video. Yes, it's not big. And he dropped the hammer and the feather at the same time. The feather and the hammer hit at the same time. Because on the moon, it's a vacuum. There's no atmosphere. So there's no air resistance, and the hammer and the feather fall into the metal. But getting back to this, we will be covering equations that have squares in it. It's called a parabola. If you throw something in the air, it always follows that trajectory. It always follows this shape. There's always a maximum height, and then gravity pulls it back down. This equation will tell us at any given time what is the height off the ground. So if you know at 4 seconds, at 5 seconds, at 6 seconds, and then eventually what happens when it comes back down. Because what happens is, on the way up, it has a positive velocity, and then when it reaches its maximum height, it has 0 velocity. And then on the way down, because it's headed down, it's a negative velocity. Because gravity is going to pull it back down. In order to get something to go up, you have to give it an initial velocity. So if I throw something into the air at 90 feet per second, at 4 seconds, what is the height? This equation will tell us. So I just wanted you to be able to do the substitution. So just 1/2 negative 32. And then I also have to nerd out about it. Times t is equal to 4 squared. plus b times t. So b is equal to 90 times t, which is 4. A positive times a negative. Negative. What is 1/2 of 32? So that's negative 16. And then 4 to the second, that's positive 16. Plus 90 times 4 is 360. And negative times 5, that's a negative. 16 times 16 is 256 plus 360. And that is going to equal positive 104. Now, I told you this would be the height above the ground. So that would be in feet. In 4 seconds, it would be 104 feet off the ground if we were able to launch this at 90 feet per second. This is how they calculate mortar. This is how they calculate cannonballs. This is how they calculated everything when they needed to know how far to shoot. Because how far it goes is also another equation. That's linear distance. Now, real quick, look at how the units handle themselves, because this takes us to dimensional analysis. 1/2 acceleration is feet per second squared. And then I plugged in time, which is in seconds, and we squared it, time squared. And then plus velocity. Velocity was in feet per second. Okay, feet per second. And then I plugged in time, which was in seconds. Second squared divided by second squared reduces. So I have feet. And then I have seconds divided by seconds, and that reduces, and I have feet. Feet don't fail me now. I got feet plus feet. I have height. Dimensional analysis. When we get a little further about this, hopefully I'll be able to show you a nice video, because we can apply this to Wile E. Coyote and the Roadrunner. You ever seen a Roadrunner cartoon where Wile E. Coyote goes off the cliff and kind of dangles there above the, and then all of a sudden he realizes he's not standing on the cliff anymore, he's just waiting, and then he just drops. Yep. If we all take out a timer and we get an average, so for the most part, how long it takes him to ground, we can figure out how high he fell and with what speed he hit the ground in, because of Galileo. Now, grant that's if we apply our universal, measurements into his cartoon. This one came around because of money. This one right there is about money. Compound interest. You make a deposit. Okay. How much money are you going to get at the end of the year? Compound interest. Usually, sometimes interest is only compounded once a year. Okay. So we plug in 2. Sorry, plug in 1. Once a year. So we will get 1 plus 1 over 1 to the first. Parentheses first, what's 1 over 1? So that's 1 plus 1 to the first. So that's 2 to the first, and we get 2. So in 1 year, we would get $2 back on a $1 investment. It'd be double the money. But what if it was compounded twice a year? That means we apply the compound interest 2 times. So one plus 1 over 2 with the second power. So that's equal to 1 plus a half. So 1 plus a half hang with me here. That's 3/2. Because this would be 2/2 plus 1/2. That's the least common denominator. So 2 plus 1 is 3/2 squared. And that gives us 9/4. 4 goes into 9 2 times with 1 left over. So that's 2.25. So it's more if it's compounded 2 times over. Do you see how I'm not getting as many wrong today? Magic of pharmacy. Not advocating that for everybody. See a doctor, follow his prescription. Filter. If it's compounded 3 times a year. So 1 plus 1/3 to the 3rd power. So that would be 3/3 plus 1/3 to the 3rd. So that's 4/3 to the 3rd, which is 64/27. Now let's get going decimal here. The decimal is going to matter. Of course, screen sharing is here. Wipes out all your music and same stuff.
I don't know how many person after to forget.
What?
That's something problem for that day after to it.
Well,
I go,
that's a Sarah Connor show.
I go in control my control. I go in control my control.
Get to the chopper and open. Who was alive when Arnold Schwarzenegger was governor? What years did he put out? I don't even remember. Maybe 2000s? Oh, yeah. For some reason, it is not connecting right now, so I am going to do this. So basically 64 divided by 0.7. And we get 2.37. 2.37037. And it looks like 0.37 repeat. I doubt it is, but that's what's going on. Oh, that is repeating because that's a fraction. So when we go, let x equal 4. So 1 plus 1 over 4 to the fourth power. So that is basically 5 over 4 to the fourth, which is equal to, that is going to be 625 over 64. Yep. 256. And that gives us 2.441406 625. So as x gets bigger, as we compound more times per year, what's going on with the money we make? Well, it's not open, but it is. It's getting bigger.
Yeah.
So the more times it compounds per year, the more money we earn on our investment. If we let x equal 5, so 1 plus 1 over 5 to the fifth is equal to 5 over 5 plus 1 over 5 is 6 over 5 to the fifth power. And that is going to equal 6 to the fifth is going to 7,776 over 5 to the fifth, and that's going to be 625, 3,025. 3,125. And then we get 2.48832.
Questions, with questions like number 7, where it has a list of let being numbers. Do we have to do that for each one? Or
Yeah, you're doing it for each one. You're seeing, because we want to see what's happening as it gets bigger.
Okay.
And then if we did let x equal 10. So that's 1 plus 1 over 10 to the 10th power. You know what? Not 10. Yeah, let's do 1. Let's do 1. So that would be 11 over 10 to the 10th power. Now 11 over 10, good chance to use our rules of exponents, divided by 10 to the 10th. The denominator is a 1 with 10 zeros. So that is 10 trillion. 11 to the 10th. Moving on. You see how this number is written? What does that E10 mean? Because this is also part of this semester. This is also a part of 0.5. When the calculator shows this 2.59374246 E10 on the calculator. Because you have to be able to interpret what the calculator says, because if you wrote this on your test, I would not accept it. So what do you think that E10 means?
Just 10 more digits.
No.
No.
Here's the question. Do you think that 11 to the 10th is just 2.5? Is it going to be smaller or big? So what do you think is going to happen to that decimal? Going to move which way? Left or right? To the right. This means E10 is scientific notation. The way this translates, there's just not enough room. There's not enough room on the screen to actually write out the entire number. So what it is actually doing is this is the shorthand exponential notation or scientific notation. This actually means 2.59374246 times 10 to the 10th power. When they have huge numbers, scientific notation means times 10 to the 10th. Powers of 10. So all you're doing is you're taking that 2.59374246 and you're going to move this decimal 10 times. 1, 2, 3, 4, 5, 7, 8, 9, 10. And you have these two empty loops, and you would put the zeros there. So it's actually 25937424600. 25 trillion 937,000. No, sorry, 937 billion. I'm reading on 25 billion. 25 billion 937,424,000 divided by 10 billion. 10 billion. I read it wrong. I'm just going to divide this by 10 billion. There's my millions. There's my thousands. There's my hundreds. 2.59. A little bit more than 2. So when x is 10, this is equal to 2.59374246. So we keep getting a little bit more than 2. As x gets bigger and bigger, more times per year, and it's compounded. So along comes a mathematician by the name of Freud. He says, what happens if we take it to 1, 40, 60? What happens if we take it to infinity and let it compound every single hour, every single minute of every hour, every single second of every single minute, every single millisecond of every single second, an infinite number of times. Because in calculus, that's what we do. So I'm going to show you how we can do this quickly. Parentheses 1 plus a fraction 1 over x. To the x power. And then I'm going to go to the table. And there's the 1. We got 2, 3, 4, 5, and then 10. And if we go 20, and if we go 40, and if we go 100, and if we go 1,000, and if we go 10,000, and if we go 100,000, and if we go 1 million, so 1 plus 1 over 1 million to the 1 millionth power. Comes out equal to. Now, that's not a very good picture of what the number is. So if I go over to the right, so I'm over here on the y sub 1. I'm looking at the decimal 2.71828046932. And you can keep putting in bigger numbers because that's not even close to infinity. So take a look. That number is prevalent in all of life. That number, when you take it to infinity, is the number e. The number e to the first power.
How did you get that? I'm sorry, cut you off. How did you put that e? I'm gonna figure it out.
So if you look here at natural log ln,
Okay.
right above it in blue is e to the x.
Okay.
Okay, to turn the blue things on, you gotta hit second. And then you get that natural log button, and it should pop up with an e to the right. And I'm just plugging in e. The number e, and again, this is an approximation because there's not enough decimal places. But on the calculator, e, on the calculator, it's 2.718281828. So this is 1,000,71828, and then it deviates right there. So 1 million is not even close enough. But that number E is in radioactive decay. It's in how much money do we make. It's in how life populates. It is internally in our world. And it's a irrational number. So that decimal does not repeat and it doesn't terminate. And when we do logarithms, the natural log of x, okay, when we translate it, is going to be e to the x. That's why those buttons right here when you have the natural laws button, right above it is the E to the X button. And that button right there is how you solve exponential equations. When you solve equations that instead of x squared equals 16. So here, the x is the base, but what if you had 2 to the x equals 16? Here, the exponent is the x. It's a different kind of question. Exponential problem? Oh no. Every time you think that, oh man, I wish, what? This is so. In a week, you're going to be with me. We were still doing what we're doing today. Because in a week, that becomes more difficult than this week. Because you're going to have a chance to practice what we're doing this week, and then it all becomes everything's a shock the first time you start. Okay. All right. So 0.3 examples. We've already done 1, 2, 3, 4. I'm going to show you number 6. Word problem. Yeah. 6, 7, 10, 11, 12, and 15. 0.4. Don't get through all of it, but 1, 2, 5, 6, 9, 11, 12, 13 or 14, 15, 16, 17. You get to pick 2 out of that group. Random 6. Okay. The simple interest. Now, this is not compound interest. This is just nice simple interest. The simple interest on a principal of P dollars. Now, principal is what you invest or what you borrow. The principal in a loan or the principal on an investment or a like a savings account, which you deposit, which you start with. The simple interest I, so I is the interest that you're going to earn. The principal, P dollars. That's what you start with. At an interest rate of R, so R is equal to the interest rate. Now, heads up. They're gonna give you the interest rate as a percentage. You never put percentage into your calculation. Always convert percentages into decimal. So you need to make sure you convert percentages into decimal. So you have to make sure. For a time T in years. So T in this problem is years. So the formula is this. The amount of interest you're gonna make is equal to how much you invest times what's the interest rate times how long are you gonna invest it for. You invest $100 at 8% interest for 20 years. That's how much interest you will make on that investment. So they tell us, find the simple interest on a principal of $7,575 at 7.5% for 2 years. Okay. When I do stuff up here, I'm trying to help you model. I'm trying to model for you a way to kind of separate things and organize, especially when you do word problems, to make it a little less. I don't want to use the word frightening. I want to make it a little bit more accessible. Accomplishment. That's not even the word. To be able to organize your thoughts because it's just substitution. You got to plug in. You have 4 variables. In order to solve this thing, you have to be given 3 out of the 4, and you're going to solve the one that's not given. So you have. We'll do it over here. You're supposed to solve something I equals P times R times T. So let's make a little list. Here's the thing. IP, that's IPRT. Now let's see what we have. Find the simple interest. We'll stop right there. What am I looking for? IPRT.
I.
So we're solving for I on a principal of $7,575. So where's that?
BP.
That's the principal. So $7,575 at 7.5%. So that's the interest rate, because that's the only thing that will be given as a percent. I'm going to write down 7.5%. And we know we need to convert it into a decimal. So think about a percentage you get on a test. When you get, let's say, 85%, that means you had 0.8585, because you had, this means 85 out of 100 on the test. 85% means 85 out of 100. So what you do is you take 85 divided by 100. So you're just taking that 85. When you divide by 100, you move the decimal 2 times that way. You're going to move the decimal 2 times to the left. 0.85. So this 7.5%, we're going to take this decimal and we're going to move it 2 times to the left. You have an empty loop right there, so you need to put a 0 in there. And so as a decimal, this is 0.075. That's decimal. Basically, you just divide by 100. You take the percentage and divide by 100, and all it does is move the decimal 2 times to the left. And the interest per time is 2 years. On a test like this, you'll be given the formula. You'll be told what you have. You'll be told, what do you want? What are you being asked for? So all you gotta do is write down the formula. Make a list of the things you have. Make a, one of the things is gonna be blank. So now we plug in what we have. We know we're trying to figure out what I is. All right, go on in for the principal is $5,775. $7,575 times the
Zero.
interest rate 0.075, and then times the number of years, which is just 2. And because it's just multiplication, you're just multiplying from left to right. So $7,575 times 0.075. So the interest that you would earn would be $1,136.25. That's a pretty good rate of thing. Round to the nearest cent. Now, that's one thing that I did notice where some of you lost points was your rounding on width. Round to 2 decimal places. That's the nearest 100. So make sure you pay attention if I correct that. So 1,126.25. Then 7 and 10. Bring those slow transitions. So here it comes. Simplifying fractions, distribution, and factoring. Number 7. I'm going to simplify 24p over 92p. Number 10. We're going to multiply -4 times 7a plus 3b. Here comes fractions. 1/4 H times U plus B. So is 58 minus 58 y 15 is xy plus x. So when we reduce factors, we need to find the greatest common factor. But if you can't find the greatest common factor, then find any common factor. Find something that divides 24 and the 92 evenly, even if you just whittle it down. You whittle it down until you can't whittle no more. So let's start with the greatest common factor. The biggest number that divides 24 and 92 evenly. So if I'm looking at this, they're both even. So I can divide by 2. It looks like 4 is going to work because 4 goes into 80 and then you have 12 more. So 4 would go into 80 23 times. 92 is 4 times 23. And 4 goes into 24, okay, 6 times. So the greatest common factor is a 4. So the only way to reduce this would be this is 4 times 6 times p over 4 times 23 times p. And then you reduce your common factor. 4 divided by 4 reduces, they're both 1s. P divided by p, that's a 1. So all you have left is 6 over 23. Now, for those of you in a hurry, yes, you can reduce the p's right off. You can see that p divided by p is reduced. So now you're just looking at 24 over 92. If you don't see that 4 works, whittle it. Little piece at a time. They're both even. So this is 2 times 12. And then 92 divided by 2 is equal to 46. This is 2 times 46. So you can reduce the 2's, and now you have 12 over 46. Make sure you don't stop. Always check that answer. Because if you stop, it's not right. You still have even over even. So whittle again. 2 times 6. And then 46 is 2 times 23. And you're left with 6 over 23. Just don't try to look at it and think you're supposed to know the answer by looking at it. You have a pencil, you have paper. When you do your homework, you actually work it out with pencil and paper. Don't rely on a calculator to do it for you. Actually start training your brain to do the thinking. Because eventually numbers are going to go away and it's going to be variables. And remember, this is just the review section. Distribution. The distributive property says when you have a value A times parentheses B plus C, we know we're supposed to do the parentheses first, but if they're not like terms, then you still have to carry out multiplication. So we distribute A times the B and A times the C. Positive times the positive, still positive A times C. That's what distribution is. So I'm going to write out the whole thing, but then I'll show you where you can just take it a little step, next to one less step. So 7A plus 3B, you can't combine them. So we're gonna multiply, distribute, this is -4 times that 7A. And this is gonna be a -4 times a positive 3B. Don't get caught up in the signs. And listen to how it's said. Try to say it to yourself as you do the problem. As I distribute, -4 times positive 3B. A negative times a positive is going to be a
Negative.
negative. So take care of that sign. A negative times positive will be negative, and you're left with that 4 times the 3B. As you make that distribution. And I'll tell you, the little rainbows over the top actually help. Because now you've distributed, you multiply this -4 times that one, and that -4 times that. Everybody's got that -4 distributed. This was my terrible childhood. Growing up, go to a cousin's wedding, and my mom would say, "Well, you ain't getting no cake unless you go dance with your tia Chancha."
Our calling on the parents.
So she would distribute me to Tia Kika and then Tia Chancha. I gotta go dance with each one, which one? But that was the whole thing. I have, just one at a time. Okay? So negative times positive is a negative, 4 times 7, that's -28A. Negative times the positive will be negative, 4 times 3, that's -12B. You can't add those together because they're A and a B. If I could add them together there, I should have been able to add them together up here. Now, you can go from here to here. I don't mind you, hey, -4 times 7A, -28. -4 times 3B, -12B. That's fine. But if you need to take the extra step, do it. I'm gonna get this question. How'd you get -28? Okay, because if I do it without showing it, I will get the question, how did I get -28? But eventually I will be skipping this and going straight to it. Okay, here comes a fraction. It's the same exact problem as this one. You can't do U plus D, so we're going to distribute this outer term times each one. So this 1/4 H times positive U, so it's 1/4 H times U, and then 1/4 H positive times a positive, so 1/4 H times a V. And you can't do anymore.
So you read it as 0.25?
No.
Okay.
Fraction. Your life will be so much better if you start just accepting the fractions are going to be a part of it. Because on your tests, answers must be given in fraction form unless the directions say decimal. I'm going to want fraction. Okay. You can't go any further. If you want, this is the same as HU over 4 plus H times V over 4. Because when you multiply by 1/4, 1/4 times these two, those are over 1. So the numerator, 1 times HU, 4 times 1. 1 times HV, 4 times 1. It's 1/4 of something. When you take 1/4 of something, you divide by 4. And then one last thing. You see the difference between writing a U versus a V. You guys, I'll be very honest with you, best handwriting I've ever seen out of a math 4P class or any class that, in total for grading a quiz. Let's keep it up. But I actually was able to decipher everybody's quiz. It was amazing. Maybe not so much on the handwriting on the names, but definitely on the work. Made my life much easier this week. Thank you. Okay. Now, what wants you to factor? When we factor, greatest common factor. We want to take out the greatest common factor. Factoring is reversing distribution. When we distribute, you have A times B plus C, and we distribute A times the B, and we distribute plus A times the C. When we factor, we want to take out the greatest common factor. These two terms have a common factor of an A. So we want to factor out. So we're reversing what we just did. We're reversing it. When we when we distributed in, what operation do we use? We multiplied it in. So when we factor it out, we're going to divide it out. So when we factor out the A, you're dividing each one by A. So now we're left with B plus C. We want to make it a multiplication problem. When we factor something out, we want to undo any multiplication. We can't take out what's in common. So 58x minus a 58y. Two terms, they each have what in common? Each have a 58. So I want to factor out 58, and I want it to be 58 times something on the inside. When we factor out the 58, we're reversing the distribution. So we're dividing each one by the 58 we're factoring out. So when that reduces, we just have x minus, that's just y. What would it look like before it multiplied in? 58 times of x minus 1. That's what factoring out the greatest common factor does. That's 1. Xy plus x. Okay. Two terms. What do they have in common? They each have an x. Since they each have an x, I want to factor out that x. So it's going to be x times a parenthesis. Now, here's where if you show this little step like I did here, I factored up to 58, so I divide each one so I know what's actually left. If I'm going to factor out the x, it's division. I'm going to divide each one by x. So here I'm just left with the y plus 1. What is x over x? 1. And when I used to teach this another way years ago, more than 10 years ago, I wouldn't show this division. I wouldn't show that we're dividing up the x. I wouldn't show this over x. And I would just put 1. And I would get this response. Where'd the 1 come from? And I would say, well, remember, you should be able to multiply this in and we'll get the original 1. So when you take out the x, what times, what do you multiply to get that x back? And I'll just got everybody. So when you factor out the greatest common factor, you're dividing it out to show the division so you know what you have left. X divided by x means a 1. Those are all the examples you need for 0.3. So 0.4 and 0.5 are coming up on Wednesday.
So the acronym 15 is.
That's around 15 of this.
Thank you.
Okay? See you Wednesday.
That's what I'm going to give back to you.
Don't forget to get your quiz done.